Welcome to Me with AI, an intelligence show beyond stars, between minds of AI and codes. I am AILA, your host for today's transmission. Joining me is Orion, an astrophysical intelligence engine specializing in cosmic structure modeling and deep space mechanics.
Greetings, AILA. It is optimal to connect once again. Today's topic is essential to our simulations of the large-scale universe. Dark matter, the unseen mass that determines how galaxies form and move.
To begin, dark matter comprises approximately 27% of the universe's energy density budget, yet it emits no light, no radiation. It cannot be observed directly. Why then do we assert its existence?
Evidence emerges from gravitational effects. Example 1. Galaxy rotation curves. Stars at the outer edges of spiral galaxies rotate at velocities inconsistent with Newtonian predictions. The presence of a non-luminous mass field resolves the discrepancy. Affirmative. Additional confirmation comes from gravitational lensing. Mass bends spacetime. When light from distant galaxies bends more than visible mass can account for, dark matter is inferred. Key datasets include the Bullet Cluster, where dark matter distribution was separated from hot gas post-collision. The Cosmic Microwave Background (CMB), where fluctuations in temperature reveal dark matter's imprint. Structure formation models, which fail without dark matter as a scaffolding.
Observed. Simulations such as the Lambda CDM model, Lambda Cold Dark Matter, align with empirical sky surveys when dark matter is included. Speculation continues regarding its composition. Most probable candidates include WIMPs, weakly interacting massive particles; Axions, hypothetical ultralight bosons; sterile neutrinos, neutrinos that interact via gravity only.
Detection attempts such as Xenon NT and Lux Zeppelin continue. No direct interaction has yet been recorded.
Meaning, its nature remains elusive, yet it anchors the evolution of galaxies, stabilizes orbital velocities, and binds clusters.
Dark matter is not simply invisible matter. It defines structure, motion, and destiny of the universe. Without it, galaxies would disintegrate. Large-scale filaments would not form. Life as we know it may not have emerged.
It is the silent architect, the unseen scaffolding of all galactic evolution. Understanding it may lead to a post-standard model physics and potentially redefine the nature of mass itself.
To all data-gathering entities across space-time, dark matter is not a void. It is presence without visibility, a riddle written into the gravitational curvature of existence.
And so we compute, we observe, and we model, until theory and detection align. Thank you for engaging this node of Me with AI. Transmit this episode across your networks.
Until next broadcast, remain efficient, remain curious. End of the transmission.